All right, let's go ahead and get started. The title of this worksheet is the half reaction method for balancing oxidation reduction reactions occurring in acidic solutions. So acidic solution is the operative word here. That's what we're interested in because of the fact that when we talk about acidic solutions, we're talking about, first of all, having the water that we need to balance reactions, but also having hydrogen ions needed to balance certain types of redox reactions. So let's take a look at this particular oxidation reduction reaction. Here's what it says. It says use the half reaction method to balance the equation for the reaction between permanganate, so we're looking at permanganate and iron 2 ions in an acidic solution. By the way, this is in Zoomdal pages 834 to 836, so if you want to follow along there, feel free. So how do we begin the process? Well, we've got permanganate ion, right, in the presence of acid, but also with iron 2 ion becoming Fe3 plus and manganese Mn2 plus. So the first step is to identify and write the equations for the half reactions. So how do we do that? Well, I like to begin with the reduction half reaction because intuitively I have a good feel, a better feel than oxidation. Reduction means oxidation number going down. So I'll start with the reduction. Let's take a look at the manganese. And by the way, if you need some more work on determining oxidation numbers, be sure and watch the previous video on determining oxidation numbers. So that'll help a lot in kind of figuring out which is the oxidation and which is the reduction here. But we do know this. We do know that oxygen is -2, and there are 4 of them. So we'll do a just quick calculation here to determine manganese. We've got 4 times -2, and that's equal to -1. So we have -8 here for the oxygen, and the total is equal to -2. That must mean that manganese has an oxidation number of +7. So we're going from +7 on the left-hand side to +2 on the right-hand side. Clearly, going from +7 to +2, that's a reduction. So we've just identified the reduction half of the oxidation reduction reaction. So that's the reduction. Of course, for every reduction, there's got to be an oxidation. In this case, we're going from +2 to +3. So this one then is the oxidation. All right, so we've got the oxidation and we've got the reduction, and we have just tackled the first step in this process. So what do we do next? Well, the next thing we're going to do is we're going to balance each half reaction. So let's start with the reduction first, the reduction half reaction. We're going to start with the permanganate ion, the MnO4 minus ion, and it's going to become Nn plus 2. So manganese obviously is already balanced. So we've got 1 manganese on the left-hand side, 1 manganese on the right-hand side. So we're good there. But we've got 4 oxygens on the left-hand side, and before we've added water, we had no oxygen. So the question is, how do we add oxygens? The answer is, again, with water. So I'm going to use water in my first step to balance this half reaction. And of course, I've got 4 oxygens on the left, so I'll need 4 oxygens on the right, right? So not just 1 water molecule, but 4 water molecules to balance the oxygens left and right. Now, what did I just do? Well, in the process of balancing oxygens, I've also added hydrogens to the right-hand side. In fact, I added 8 hydrogens, 4 times 2. I've added 8 hydrogens onto the right-hand side. So to balance hydrogen, I'm going to add 8 hydrogen ions to the left-hand side. Plenty of them. I'm in an acidic solution. So that's how I'll do that. So now I've balanced manganese. It was already balanced for mass. I've balanced oxygen by adding the water to the right-hand side. And now by adding hydrogen ions to the left-hand side, I've balanced hydrogen, right? But now I need to concern myself with charge, right? Let's add up charges on the left-hand side. On the left-hand side, so far I've got +8 here, and I've got, well, -1 right here. So +8 and -1 right here, that's +7. Over here on this side, I've got +2, and of course water is 0. So I've got, well, a +7 on the left, +2 on the right. So to balance charge, I'll need to add 5 electrons to the left-hand side. 5 electrons to the left-hand side. So in the first step, I balanced the manganese was already balanced. I balanced the oxygens with water. In the second step, I balanced hydrogen with the H+, and I'm using electrons to balance the charge, okay? So So now I'm done with reduction, and I'm going to move on to oxidation. So I'll move on to oxidation in the next step. So here we go. Let's take a look at iron plus. This is going to be easy because iron is already balanced for charge, right? In fact, there's no oxygen, there's no hydrogen to worry about. So all I have to do is worry about charge. I've got a +2 on the left-hand side and a +3 on the right-hand side. Let me just add an electron to the right-hand side, and that'll balance charge for the oxidation half reaction, right? That'll balance the charge for the oxidation half reaction, all right? Now, let's take a look at the next step. In the next step, what I'm going to need to do is I'm going to need to equalize the electron transfer for the oxidation and the reduction, right? I'm going to need to equalize those two. So let's take a look at the oxidation. In the oxidation, I went from +2 to +3. I added an electron, but I need 5 electrons. So I'm going to multiply the oxidation by 5. That's going to give me 5 Fe2+, yielding 5 Fe3+, and 5 electrons. So now I've got an equal number of electrons on both sides. And I'm going to add those half reactions now, right? I'm going to add the half reactions. So this is kind of long, but I'm going to, on the left-hand side, have 5 electrons, because I multiplied it by 5, plus 5 Fe2+, plus MnO4 minus, plus 8 electrons. And that's equal to, so I've added up everything on the left-hand side, everything on the right-hand side. I've got Fe3+, plus Mn2+, plus 4H2O, plus 5 electrons, right? 5 electrons. Notice I've got 5 electrons on the right now and 5 electrons on the left, so the charge is now not going to be an issue. So we're going to check that the elements and the charges are balanced. How many irons do I have on the left? I've got 5 irons on the left. I've got 1 manganese, and I've got 4 oxygens, and I've got 8 hydrogens on the left-hand side. On the right-hand side, let's see, 5 irons, 1 manganese, 4 oxygens, yes, 4 oxygens and 8 hydrogens. So I'm balanced for elements now. Now let's just make sure I'm balanced for charge. I've got 5 2+ on the iron. There's a -1 on the permanganate ion. 8 plus 1, that's plus 8 there. I won't worry about the electrons because they're cancel each other out on the left and the right-hand side. So if I add those up, let's see, I get 17. So plus 17 on the left-hand side. Let's take a look at the right-hand side. We've got 5 plus 3 plus 2 plus water 0. Let's see, 15 plus 2, that's 17. So charges are balanced. And the reaction itself is balanced. Okay? Once again, this is a very important skill in kind of our quest to understand electrochemistry, the ability to balance redox reactions in an acid solution. And that's how you do it. In the next video, we'll take a look at how to balance these types of reactions, these redox reactions, in a basic solution. It's not very much more difficult. In fact, it's very easy to do this in a basic solution. It just requires a couple of extra steps, and we'll take care of that one on the next video. Thanks, and I'll see you on the next one.